Greetings, everyone. My name is Floyd Christofferson, and I'm welcoming you today to our webinar on unleashing the future potential of your NVIDIA DGX servers. I'm joined by Eric Bassier, who's a senior solution marketing for Hammerspace, and Simon Robinson from ESG.
Hi, Floyd. Excited to be talking about this today. And Simon, thanks for joining us.
Yeah, thanks for having me on. Really looking forward to our discussion today.
And for everybody attending, this session will obviously be recorded and be available after the fact. There is a Q&A box. So as we cover the topics today, please enter your questions in the Q&A box and we will get to them either in the flow or we'll wrap up at the end. So with that, let's get started. Today, we're really going to be talking about a lot of features that are coming out and which was announced today in Hammerspace software version 5.1. And really the focus of this, although we put it in the title, Unleash the Power of Your DGX Servers, that really is the focus. Because what we're seeing and the enhancements that we've made to Hammerspace are really addressing a problem set that exists within the industry as things transform with much more high performance use cases around AI. Before we get started, for those of you who are not familiar with Hammerspace, I'm going to take a couple minutes and just give you an overview of what it is, and that will help set the context for what we're going to be talking about next. So Hammerspace is software that was specifically designed to solve the problem where data becomes distributed across different silos within a single data center, across multiple data centers, or across cloud resources. And particularly for AI use cases where data may need to be aggregated from multiple sources, this becomes a major problem. What Hammerspace does is it aggregates the metadata from, and what we call assimilating the metadata from all storage from any vendor. Remember, Hammerspace is software. And so it enables you to stitch this into your environment to create a global view across all of them. This is standards-based, so any protocol, no client software is required on the servers or applications, changes to applications. You look at file shares, whether via any protocol, the same way you would if it was local storage or a single file or object storage. But this ability to have the this abstraction layer, a high performance abstraction layer, so that everybody is looking at the same files, means that data motion and data data orchestration can happen non-disruptively in the background, even on live files. So the context of this really is, as we look at high performance use cases that require GPU computing, the problem is, how do you make sure that you can get the most out of your GPU resources? And especially as enterprises and organizations are looking at, should they or how can they embark on an AI journey? Is it on-prem GPU compute or is it in the cloud? How do you manage this? So that's sort of the stage setting what we'll be talking about today. The release, the Hammerspace release, is specifically designed and has features that enable this type of workflow. But to set the context, I'm going to turn it over to Simon, who will talk a little bit about what's going on in the industry and give you context for how this might apply in your environment as well. Simon?
Yeah, great. Thank you, Floyd. And again, thanks for having me on the session today. Really looking forward to this discussion in what is an extremely exciting time in our industry, though, as we'll discuss, not without its challenges, right? So my name is Simon Robinson. I'm an analyst. I'm principal analyst with the Enterprise Strategy Group. If you're not familiar with ESG, we're part of TechTarget, and we produce a whole bunch of research, insight, and data perspectives really on how the enterprise IT market is evolving. We provide counsel to our clients on how best they can take advantage of these changes. So obviously a huge focus area for us right now is around AI. What else? And I'm going to be sharing some of our perspectives today on what we see as the opportunities, how we're thinking about the market more broadly, what we see in terms of adoption trends, even at this early stage. Also be touching on some of the challenges that we see, because this is a really, really interesting point, because we have a brand new kind of disruptive technology opportunity. We've got a transformative opportunity that almost every organization is looking to take advantage of to some degree or other. Yet essentially, very few organizations know where to start when it comes to their AI journey. So, massive opportunity, lots of confusion, and we're spending a whole bunch of time trying to understand and advise clients how to move forward. So I think one of the first things you could say is that you could be forgiven for thinking that the AI market didn't exist until November 2022 when ChatGPT first launched. Obviously, it did, but what ChatGPT did was it made the promise and power of AI relatable to the average person, and I guess in particular the average business executive who could suddenly see and directly access actually the power of generative AI, and immediately gain a sense of how AI could be put to use within their own organizations. And as they say, the rest is history. AI, generative AI in particular, has gone from nowhere to being a board level discussion and opportunity. Let's show this first chart. So this is some very new data. And we asked the respondents here to rank these strategic IT initiatives from most to least important. And what we're seeing here is the percentage of respondents that ranked each initiative as the number one priority. So this is quite incredible. Within 2 years, Gen AI is already ranked third overall, right? And I think we're going to talk about kind of why that is. I think at a high level, is this that organizations just have a fear of missing out? Is it first mover advantage? I think all of these things are true. Either way, we're seeing incredible level of attention and interest. Let's dig in a level deeper to get a sense of where organizations are on their Gen AI adoption journey. And we asked organizations to characterize their adoption plans. First thing to say is that no respondents to this survey said that they had no interest at all, right? So about 63% are in pilot or proof of concept. They're in early production, or even some of them say that they're in mature production. That's interesting to understand sort of what mature looks like. I mean, we certainly speak to some organizations that have actually, made an investment in AI and Gen AI, and they've seen an immediate return and a doubling down on it for sure. But really, to understand, I suppose the question is, why are we seeing such levels of interest and adoption? I think a key thing is that there is significant optimism that Gen AI in particular is going to bring significant value. So in this survey, we've provided respondents with 11 kind of value options, if you like, and over half of them said Gen AI would bring transformative or significant value for 9 of these values in areas such as innovation, creativity, productivity gains, customer satisfaction. And I think this is a key reason why the opportunity is so significant, is that Gen AI in particular can be applied to so many different parts of the business processes, whether that is creative marketing, content generation, productivity gains in terms of improving the software development process, reinventing the customer engagement process through intelligent automation of the customer support journey, for example. So, excitement clearly is substantial. The question is, how do we tap into that excitement? How do we deliver solutions on this promise? And the biggest question we hear, honestly, is, well, how do I get started? I think part of the challenge here is that organizations want to get to the outcome. They want to get to realizing the value. They want to get to inferencing, but they need to figure out how to get there, right? And that is can be a complex journey that requires a substantial set of resources, investment, and commitment from the business. So we're sort of transitioning now from the kind of why we're doing this to the sort of how are we doing this. And as I say, this is where it kind of gets interesting. There are obviously multiple ways to actually implement an AI strategy, and Floyd already touched on this. You can go to a public cloud hyperscaler. You can go to one of the increasing number of service providers that are offering things like GPU as a service. And we do see many organizations utilizing both of these options, especially in this initial phase. But for many organizations, if not most, at some point they are going to want to run and build AI in their own environments, either exclusively or in a hybrid cloud fashion. Why is that? Well, it's for a couple of reasons. To a large extent, that is where their data is, right? Their data is on-prem, and there is a data gravity aspect to this. So we need to bring AI and compute to our data. But there's also a notable kind of risk, compliance, security aspect, right? This data is valued very, very highly to the organization. And many of them just don't want to release it outside of their own data centers. And we're going to kind of dig into this shortly. I think the bottom line is that it's pretty clear that AI, including Gen AI, is driving kind of an inflection point in the technology stack with a vastly different set of requirements that are needed around supporting this accelerated computing environment. In fact, as we can see here, 63% of respondents to our surveys said they need to modernize or change their supporting infrastructure before they can proceed with a Gen AI initiative. And a lot of focus here is obviously on the GPU side. What doesn't get talked about as much is the data and storage element. But clearly, this is critical because good AI models require good data and lots of it. And that sounds kind of as easy to say, but the reality is often much more complex. How do you ensure you feed good data and only good data into a model? We have all seen, heard about the consequences if you do not. If you put in incorrect data, out-of-date data, personally identifiable data, proprietary other sensitive data. If you put that data in, then you get bad data out. And that's where we get the hallucinations and other negative consequences. If that happens, then you're not going to have trust in the model. And that investment is going to be wasted. And the extent of these data challenges is being kind of consistently recognized in our research. So we did a survey. This is actually a different survey that we did last year, not just on Gen AI, but on AI more broadly. We asked organizations what the top challenges were when encountering and implementing AI. The top response, ahead of things like high costs, measuring ROI, skill shortages, privacy concerns, was a lack of quality data to train models. And that to me is really interesting. So I think to a great extent, that data does exist within the organization. The challenge they have is getting that data to the right place, to get it into the model at the right place, in the right time, in the right way. And that's where we kind of start to expand our focus to the storage environment. I think one other thing quickly to add is the inference stage, right? Because as I mentioned, this is where organizations will realize the value of AI is through inference, right? And this is where organizations are also looking to leverage their own data. And it's actually, I've included this as a data point on the slides, but 84% of organizations said it was important to incorporate their own enterprise data to support their Gen AI initiatives. So, this is where things like RAG start to come into play. And again, this is where the data management piece becomes critical. How exactly does an organization incorporate their data into a Gen AI model, especially if we're thinking about this hybrid cloud environment? How is that process managed and optimized? And again, for me, this is where it gets really interesting, because it obviously highlights the importance of data, but also highlights the absolute necessity for organizations to think very carefully about their data and storage architectures when building their AI infrastructure. And if I actually advance a slide more, we can see here that storage is already being viewed, along with many other kind of elements of the infrastructure, as a potential weak link in delivering an effective AI and ML environment. So what does that mean? So I think the storage environment, to me, has multiple dimensions, and the Hammerspace folks are going to talk much more about this. Obviously, the cost aspect is really important. What's really interesting is the extent to which cost and performance are tightly linked. It really is about getting maximum value from the high-cost GPU estate, and I think organizations are going to be looking for ways to reduce or at least minimize their storage costs. They're spending a lot of dollars on their GPU environment. How can I optimize the rest of that environment to keep costs as low as possible? On the performance side, IT has always been kind of playing whack-a-mole when it comes to performance. We thought we had solved the storage performance problem with NVMe and all flash and things like that, but no, here comes AI and GPU to kind of blow that out of the water. So again, the things that Hammerspace is doing here, I think, will be really interesting and an important contribution to the discussion. And we're going to hear more about that today. And then one final thing I wanted to cover was kind of the energy element, and again, I think this is being talked about more and more. Let's face it, GPUs consume a lot of power. I read that an H100 running 60% utilization will consume as much power annually as the average US household. And this presents a real challenge for organizations. Obviously, it impacts cost, especially in regions where power is expensive and can be fluctuating highly. Access to sufficient power is also a growing issue, and there are plenty of stories out there about data centers that are being built but can't operate because there isn't enough power, or various moratoriums on building data centers. And the prospect of large-scale AI adoption, substantially exacerbates this issue. And I think you can actually think of power availability as the number one barrier to AI adoption on a global basis. Is something we have to solve. And then there are the kind of sustainability impacts of this, right? And, how can an organization embrace AI while still honoring their commitments to net zero and other sustainability related mandates? Now, research shows, see here, sustainability continues to be a very important area for many customers. And this does apply to AI infrastructure as well. And they want to see that vendors are taking this issue seriously. Now, obviously, the political climate is changing a bit here. It's probably too early and too dangerous to begin speculating on what might happen there. But what I don't see changing is this fundamental focus on energy efficiency, because that's a problem we have to solve more broadly to make AI more real on a broader basis. So that's probably a good place for me to pause. Thanks for listening, and let me hand it back to Floyd.
Thank you very much, Simon. And I think it's very important, it's not just sustainability, but as you're looking at AI journeys that might start from very, very small environments up to very large, it's a cost factor. as well, and in even the availability of power, especially when you get to the large ones. And so that's a good segue to pitch it over to Eric, where, as we talk about, GPU computing, we're really seeing this convergence of what was traditionally an HPC level of performance that now needs to be available in the enterprise without building a whole dedicated bespoke infrastructure just for this. It has to seamlessly merge. And Eric will cover the new features that are coming out in Hammerspace version 5.1 that will accelerate this. Go ahead, Eric. Thank you.
Yeah, thanks a lot, Floyd. So keying in on a couple of things Simon said, obviously Gen AI is a strategic priority. Many of our customers and many of your customers, for our partners out there, are investing in large GPU computing environments. And the latest version of our software does something really transformative. We're really excited about this announcement. The press release went out this morning. And what we're going to be talking about is how we transform GPU computing infrastructure by letting you turn the local NVMe storage that's in your GPU servers today, by letting you turn that into a new tier of ultra-fast shared storage that's part of the Hammerspace data platform. And we call that tier 0. So if you have an NVIDIA, if you've got a DGX base pod, if you've got a super pod, you're going to want to pay attention. If you have GPU servers in place today, you're really going to want to pay attention to this. And if you're thinking about investing in additional GPU servers, this new innovation from Hammerspace will have a big effect on your infrastructure. So let's get into it. Hammerspace is a data platform for distributed file and object data. And Hammerspace is deployed in a lot of large GPU computing environments. And what we're hearing is, to key in on a couple of things Simon said, infrastructure cost is a big issue. Power constraints are a big issue. And time to value is a big issue. How quickly can you start to generate ROI on that big investment that you've made in your GPU infrastructure? Typically, when we are engaging with customers, they've invested and deployed their GPU computing layer. And then as a second phase, they're looking at external flash storage systems to feed the data to those GPUs at really high speeds. And just evaluating, purchasing, and deploying those external flash storage systems, that takes time. In addition, those systems consume rack space, power, and of course, they're quite expensive. Meanwhile, when we look at the GPU servers themselves, these GPU servers have a large amount of local NVMe storage that typically goes unused. There's a few reasons for that. One is the data or the storage is only accessible to the local GPUs inside that server. It's not accessible to other GPUs in the cluster. 2, it's not typically protected. So if a GPU server goes down, you don't want to have any risk of data loss. And 3, it's difficult for the data users to have to manually move the data between the local storage and some external shared storage. And so it just typically goes unused. And the capacity points are not small. We were looking at a super micro server model this morning that could have 16 NVMe drives. And if you have 30 terabyte drives in there, you could have hundreds of terabytes of local NVMe capacity sitting in that server. By next year, as the larger SSD capacity points come out, it's going to be possible to have 2 petabytes of storage in a single GPU server. And if you're an NVIDIA customer today, DGX servers come with the storage. It's just part of the BOM. And so what Hammerspace has now done with the latest version of our software is we can make that stranded capacity inside of these GPU servers part of the Hammerspace global data platform. We can make it part of a global namespace. And by doing so, we unlock a new tier of ultra-fast shared storage that we call tier 0. By unlocking the use of that capacity, you're going to be able to reduce the amount of external storage that you need. So you're going to reduce costs, you're going to reduce power. Because it's so fast, And because we take advantage of an enhancement to the Linux kernel that I'm going to be talking about in a little bit, we can reduce checkpointing time on the server by a factor of 20x, even 100x, so you can free up valuable GPU cycles to do more work for your business and increase that ROI. And this capacity can be brought online literally in a matter of minutes. We have a customer I'll talk about next that brought on petabytes of tier 0 capacity, that it made that available in a few days. So you can deliver faster time to value and get to work quickly. So let's talk a little bit more about tier 0. One of the reasons we call it tier 0 is because it is now a new tier of storage within our global data platform. Hammerspace is now the only data platform that can span tier 0 with microsecond latencies all the way out to a deep archive. And as Floyd showed, that could include public cloud storage, in a different site. And we can do all of that in a global namespace, all of that in one data platform. Really powerful. And this is not a concept. We do have this deployed in production. This is a customer that has deployed tier 0 in a multi-petabyte AI training environment. And just to bring this to life a little bit, they had a large number of GPU servers, over 1,000, and each one either had 31 terabytes of capacity or 62 terabytes of capacity in each server. And when we approached them about this opportunity, they were in the process of deploying external storage. We said, hey, what if we could make that, many, many petabytes of storage that's in your GPU servers? What if we could make that a tier of shared storage? They loved the idea. We worked with them on that. They've now deployed over 30 petabytes of tier 0 storage in their production environment. And as I said, they were able to bring that online in a matter of days. So really delivering faster time to value so they can get to work on training and doing the things that they're doing. This tier 0 is really just the latest enhancement or the latest innovation in how Hammerspace is making GPU computing more efficient. And if we look at the progression of NAS architectures, scale-out NAS systems are one of the architectures that's considered for GPU computing and for AI training and inferencing. But as we look at the progression of these NAS architectures over time, even the most modern all-flash scale-out NAS system, something like VAST Data, and even when it's using GPU Direct, the data path between the external NVMe storage and the GPUs is still really inefficient. What this is depicting is there's about 8 or 9 hops or network retransmissions that have to occur between the underlying NVMe and the external storage and the GPUs. Now, Hammerspace changed all that at the start of this year when we introduced our hyperscale NAS architecture. It's a standards-based parallel file system architecture. And as shown by separating metadata out, we also establish a direct data path between the client and the external storage, in this case, the NVMe storage that's in the external storage server. Now you can see this cuts the number of network retransmissions in half. And hyperscale NAS improves performance by about a factor of 2x versus these scale-out NAS systems. And this is a big reason why Hammerspace is used in such large GPU computing environments today at places like Meta, Los Alamos National Labs, and many others. Now, this tier 0 architecture is just the next step or iteration in hyperscale NAS. It's fundamentally the same architecture. It leverages the standards-based parallel file system construct that we put in place. The client servers or the GPU servers connect to our metadata server. And now, because the NVMe is co-located with the GPU, our parallel file system can now take advantage of an enhancement that we've made and contributed to the Linux kernel that creates a shortcut between those GPUs and the local storage to further reduce latencies. We call that NFS protocol bypass, and we're going to talk about that when we get into how it works. Now, by reducing the need for external storage systems and by speeding up processes like checkpointing, Tier 0 can have a very significant savings and a very significant ROI. Now, if we look at a very large scale training environment, let's say it's 1,000 GPU servers and each one of those servers has 128 terabytes of capacity. So again, for you NVIDIA customers out there, this might be an NVIDIA SuperPod with a bunch of DGX servers, and each one of them has 128 terabytes of capacity. For the purposes of our analysis, let's say that storage is already in place. It's a sunk cost. The other component of savings, really of return on investment, is that because that storage is so fast, because we can unlock it, we've seen through an analysis that we've now published online, you can reduce checkpointing time from minutes to seconds. And that means you can reduce the time that the GPU server is doing checkpointing, so you unlock more GPU computational cycles to do other things for your business. The other thing is you can increase checkpointing frequency because the checkpoints can complete more quickly. That also has a time savings effect because it reduces average recomputation time. And this is quite substantial, as we'll see. From a pure cost savings and power savings perspective, if we can turn on or allow you to use petabytes of storage capacity that's just sitting in your GPU servers, you can reduce your external storage costs significantly. And at this scale, you're talking about roughly $40 to $50 million of external storage costs that can be avoided. The power savings is equally substantial, and we're talking millions or even tens of millions of kilowatt hours saved over a few years. And this may mean, especially if you're in a data center where you have no more power or you're under severe power constraints, as Simon talked about, this might mean that you can actually have the ability to deploy more compute resources because we've eliminated the power requirements that would be used in this external storage. So the savings is quite substantial, but it improved ROI on your existing GPU investment is equally as substantial. So it turns out that by using that ultra-fast local NVMe storage, by taking advantage of that NFS protocol bypass, we can save, in a large cluster like this, we can save hundreds of thousands of GPU compute cycles per year, hundreds of thousands of GPU hours saved. And even conservatively estimating the cost of a GPU of $20K to $40K per GPU, that equates to about $25 to $30 million of GPU opportunity cost that Tier 0 can unlock in your existing infrastructure. Another way to say that, it's like adding about 10 to 15% more GPU computational capacity with your existing investment, with the GPUs that are there today. So this is really powerful. Now, this is obviously for a very large scale environment, but Tier 0 has an excellent ROI at any scale. Even if we look at, for example, something like 10 petabytes. So if you have maybe between 10 and 20 GPU servers, maybe that's your NVIDIA base pod, and each one has 100 terabytes in there, you might have 10 petabytes of Tier 0 storage that's just sitting in your environment today. And if we can turn that on with Hammerspace, you might save 3 to 4 million in or you might avoid about 3 to 4 million in spend for external flash storage hardware. That's the servers, that's the NVMe devices inside those servers, it's the networking. About $500,000 of energy cost savings over a few years, a few million kilowatt hours. And again, that might be the difference of your ability to deploy more compute in your environment. And this, just at this scale, this would save about 3 to 5 racks of data center space that would otherwise be used for those external storage systems. So even at smaller scale, this is quite substantial. If you're interested in what this might look like for your environment, go to our website now, and on the new page that talks about Tier 0, we have a Tier 0 savings estimator. Figure out how much storage capacity you have in maybe your NVIDIA base pod or SuperPod, or if you're using GPU servers from Dell or Supermicro or Lenovo, go figure out how much you have, enter that capacity in our savings estimator, and we'll spit out these numbers for you. And of course, if you want something more customized for your environment, there's a button right there where you can get in touch with our team and we'll work on a custom assessment for you. So the savings is really powerful. Now let's talk about how this works. And I want to start by just recapping Hammerspace's standards-based parallel file system architecture that we call hyperscale NAS. This is what it looks like. If you've got a GPU client server, it's connected to an external NVMe storage server, and our Anvil metadata servers are depicted here as well. Like other parallel file system architectures, metadata is separated out from the data path, and there's a direct data path between the client and the external storage. Unlike every other parallel file system out there, we do not require any proprietary client or any client software that needs to be installed on that GPU server. It's just Linux. So it's an NFS 4.2 client. We use capabilities that we've engineered and contributed and have been part of the NFS 4.2 client since 2018. So that the client requests a layout from our metadata server, we return the layout, and it writes the bits and files directly to that external storage. So I want to reinforce this, and I'll do it again later. There's no Hammerspace software that you need to put on your DGX. There's no Hammerspace software that you need to put on your GPU server. It's just Linux. Furthermore, there's no Hammerspace software that you need to put on the external NFS server. It's just Linux. Now, the way this works in our file system or our global data platform, that NFS server simply becomes a storage volume in Hammerspace. It's, the mount point, let's say NFS v3 node 1. It's a storage volume within Hammerspace. At this point, you can read and write data. You can access the data using standard industry protocols, NFS, SMB, and S3. And you can also set data protection and data, orchestration policies to be able to automate the protection of the data that's in that volume and the movement of data that's in that volume. Now, within a GPU server, there's fundamentally the same construct. You've got an NFS client, you've got an NFS server. Let's say that this NFS server is NFS v3 node 2. That's just another volume within Hammerspace, and all those same capabilities now apply. I think you maybe are going to start to see how this works as we extrapolate this out to larger GPU clusters. Before we do, though, I want to talk about that data path inside of the GPU server, because it's a little more complex than that. This is what the typical NFS data path looks like inside that GPU server. The application goes through these different layers of the Linux kernel, the NFS client, the network stack, and including things like the NIC, the NFS server file system, and then the underlying storage. Our 5.1 software is the first to take advantage of a new enhancement to the Linux kernel that we call NFS protocol bypass. So as the name implies, and as this shows here, NFS protocol bypass is a new handshake that basically says when the client and the server know that they are co-located on that GPU server, it creates a shortcut that bypasses these layers of the NFS stack here inside the kernel so that you can go directly to the underlying storage. And this has the effect of further reducing latencies and increasing IOPS and bandwidth by about 12x inside that server. Everything here this has been, the changes that were made to the Linux kernel have been engineered by Hammerspace, but we've contributed them to the Linux kernel, and those are available now in the latest release candidate. Many of you know we've got a couple of the Linux kernel maintainers on staff, including our CTO, Trond Mikkelboost, who's been the NFS kernel maintainer for many, many years. So we're doing these changes from the inside, and this is really what unlocks that ability to deliver, not only to make this local storage part of a global file system, but to unlock that very low latency performance to do things like reducing checkpointing time from minutes to seconds. So that's the NFS protocol bypass. And now if we just zoom out a little bit, we've talked about how an external storage NFS server just becomes part of the Hammerspace global data platform. It's a storage, it's a volume in Hammerspace. One GPU server, maybe that becomes another volume within Hammerspace node 2. And you can kind of see how this starts to build out. Node 3, node 4. If you have a very large GPU computing environment, hundreds of GPU servers, even thousands, Hammerspace's architecture can support that scale. That's where a lot of the work we've done, going back to the work we did with Meta, was such a critical technical proof point for our architecture to be able to operate, at that performance, at that scale, because we knew if we could operate at that scale, we can operate in your enterprise, we can operate at any scale. And lastly, the Hammerspace data platform, it extends to other tiers of storage. You could have tier 1 storage, tier 2, even archival storage. It could be, you could add a bucket, or you could import a bucket into the Hammerspace global file system, and that becomes part of our file system as well. So the power of our global data platform is really, really special, and that talks to a little bit about how this works. Now, the last slide I'll talk to that sort of tries to bring this all together is, let's look at something that looks a little bit closer to an environment that you may have. So here we're just depicting 2 GPU servers. We're depicting some external NVMe storage. First, install Hammerspace. And I'm showing our Anvil metadata servers here. Just as a quick reminder, Hammerspace is pretty lightweight. You can install the components of our software in under 30 minutes. You can add the volumes from either the storage that's in the GPU servers or any external storage you want, add that into our system, and then you can start to do some things which we'll talk about in a minute. I'm going to reinforce this one last time. There's no Hammerspace software that needs to be installed on the GPU servers. There's none that needs to be installed on the external storage servers. It's just Linux. Now, let's say that the top, that's your tier 0. Let's say that the bottom, this is your tier 1. And this is a single global namespace. It is a single global file system. Once you have this architecture in place, now Hammerspace can do some really amazing things. We can automate the data protection. So as shown here, as new files are being written or new objects are being written to GPU server 1, through Hammerspace policies, we can choose to make copies of that data. So we're creating different instances or instantiations of it across your environment. In the case of one of our customers today, they have a policy that says when new data is written to one of their GPU servers, they make 2 copies of that. Hammerspace makes 2 copies of that. One on another GPU server, a second on AWS S3 on external cloud storage. So they have 3 copies of their data at any time. If the GPU server goes down, their data is protected, it's available. And this is very fast, it's resilient, and it's performant. The second thing you can do is you can automate tiering policies so that you may move the oldest files off of your GPU servers and move those out to external storage systems. So that, for example, with something like checkpointing, you can set up a simple policy and you're always writing your most recent checkpoints to local storage, so you get that performance benefit of it. Meanwhile, the older checkpoints are stored somewhere else and they're protected, so you can quickly recover from those. So tier 0 is really powerful. We're very excited about it. And again, it has some really amazing capabilities to transform GPU computing infrastructure. You can free up by unlocking that capacity, that stranded capacity. It delivers significant cost and power savings. By using that very fast local NVMe storage along with this new NFS protocol bypass capability, you can speed up checkpointing and get this ultra low latency tier of shared storage. And lastly, you can bring it online in a matter of minutes. You can accelerate time to value and get a better return on that investment that you're making in your infrastructure. So that's tier 0. And it's what I think we're most excited about in terms of our version 5.1 software. But we have a lot more in our 5.1 software. And I'm going to turn it over to Floyd to take us through the rest of that. Floyd?
Thanks, Eric. And you're right. I mean, there's a huge focus anyway within Hammerspace on not only performance at the extreme edge, but also making sure that those same capabilities that are available at the extreme can actually start at very small environments. And it's got that linear scalability that is crucial. Another thing that I'll note here is that Hammerspace is software that can be deployed anywhere. It can be deployed on VMs, cloud instances, bare metal, and we have hardware partners that also put together bundles that enable you to easily deploy. But the key here is in version 5.1, although the tier 0 is the most exciting, there's a few things that are bear mentioning. And this is in particular as we look at whether it's AI or even in general enterprise use cases, there's multiple protocols that need seamless access. So, and in particular, maybe data might arrive from an instrument that is SMB or processed via NFS, or needs to be accessed either by users or applications that need to see an object store. And so that's why with version 5.1, we're really proud to announce the introduction of an extremely high-performant S3 protocol to join with our standards-based NFS and SMB protocols on the front. This is not a bolt-on of just an S3 funnel into the system, but S3 is a fully functioning peer to both NFS and SMB. It unifies the namespace across them all and unifies permissions, which means any user who is accessing or any application that is accessing from any protocol is seeing the exact same view. And this is really designed for extreme scales. I mean, to the point that, we can, within this system, each of our DSX nodes, and again, these nodes, our Hammerspace software is deployed in one instance or one software load that includes the Anvil metadata servers and our DSX data services nodes that can scale out to 60 nodes for extreme parallelism and performance. And oh, by the way, we can have up to 16 of these that can be distributed across multiple locations. But each one of those DSX nodes can be an S3 server and can have S3 services, which means that from a user's perspective or an application's perspective, they see that the file and folder structure is what they would expect, and that translates directly from file to object. There's no difference. If you're coming in through an S3, it looks like an object. If you're looking at NFS or SMB, it looks like a file with all of the metadata, permissions, and access aggregated within Hammerspace. And this can go to extreme scales. I mean, we can have up to 2,048 S3 servers and a maximum number of 20,000 buckets per server. These are insane numbers, but as you get into the very, very largest environments, these become absolutely essential. And we performance test this so that, that parallelism and the ability within Hammerspace, again, standards-based, install nothing on your servers or no changes to your applications, and you get the full benefit of this. And then with this, gone are the days where you have to shuffle data back and forth between silos, because underneath this, as we see the Hammerspace platform, underneath this, it can be storage from any vendor. Not only the storage that Eric was referencing that might be in the GPU server, but this could be object store, file stores, cloud-based storage, remote storage for DR and other things. And all of this is unified in a high-performance environment with Hammerspace. So that's S3. We're very proud of this, and it's gone through extreme testing at large scales, and really helps with the standards-based capabilities within Hammerspace. But wait, there's more. That's not all. Additional features, again, within Hammerspace, reminder that an administrator sees Hammerspace through a GUI, through CLI, or through API access. Users don't even necessarily know that Hammerspace is there. Or for an administrator, they need they are able to use Hammerspace to have global control over all of their resources. So with 5.1, we're introducing an update to our administrative GUI, and this includes tile-based feedback, so individual administrators can set up the tiles as they like to get direct feedback on data mobility, capacity, utilization, manage policies and objectives across the entire cluster. And that includes all of your storage that might be behind Hammerspace. And to really, based on the work that we've been doing at Meta and other very, very large environments, this new release also introduces at least a 5x increase in data mobility. The ability, again, behind the scenes, without interrupting user access, the ability to place data where it needs to be. Our data in place assimilation, that's what we call the ability to pull the metadata, extract the metadata out of your existing storage, leaving the data in place, making it that much faster to be able to put Hammerspace into your environment without disruption to your users. And then, of course, a key use case for that Eric touched on, but I want to emphasize, is that you may not be able to get GPU servers in your local environment. You may need to be able to go to cloud. That's cloud bursting. Because Hammerspace can be easily deployed with an Ansible recipe or other capabilities within all of the major cloud providers, it means you could spin up a Hammerspace instance and take advantage of even the GPU, the tier 0 capabilities within GPU servers in the cloud. Run your job and turn them down again, because Hammerspace is one global file system that connects both your on-prem and your cloud-based storage and across multiple sites. So that increase in performance, it has a direct benefit for users that are doing anything with moving data. Metadata performance continues to increase, and then driven by our biggest customers, of course, we continually expand the max limits for volumes and storage systems, such that unless you're at the highest end of the scale, you may not even know or care that we can go that big. But if you are at the high end, that's very important. The three-way resiliency, this is where already Hammerspace, our metadata servers are HA and protected in multiple ways. But being able to do three-way HA across them, and then especially as you go across multiple clusters or sites, to have this quorum server, that's very important. And then there's other features that are in this. I invite you to go to our website where you'll get a much more detailed view of things. So sort of to wrap it up, Hammerspace software is designed so that you can span any storage and bridge any storage in your environment. That means existing storage. It means that if you're experimenting or looking to dip your toe in the water for AI workflows, or maybe you already have an AI strategy and you want to grow out of and avoid having to build a bespoke new AI tier within your environment, Hammerspace is a software that is designed to do this. Standards-based, runs on anything, no client software, as Eric has said, no client software required, no alterations to your existing system. It's standards-based because we want you to be able to take advantage of this without having to get yourself locked into a proprietary environment. And we're nearly at time. Eric, Simon, anything else you want to add as we close out?
Yeah, just that we did get a couple questions that came in, really good questions. So let's just take a couple minutes to address those, Floyd, and then I think we can say a quick couple words to wrap. The first was, do we have a template or tool to help our clients determine the amount of resources they can reclaim? And we do. And I think it's a great call to action for everybody out there. if you go to hammerspace.com, right on our main homepage, you'll see a big image that'll link you to the new page that we've created that talks about Tier 0. And on that Tier 0 page, you will see a savings estimator. It's very simple. And if you have GPU servers today, if you can figure out how much storage capacity is available in those GPU servers, figure that out, and then just enter that number into the calculator or the estimator, and we'll tell you exactly how much you can save in terms of external storage, power and energy costs, and power consumption and rack space. So it's a great thing to go do. Go do that, check it out. There's a button right there if you want someone from Hammerspace to get engaged with you and do a custom assessment. We're ready to do that as well. So that's one. Floyd, the second, I think kind of as you were talking about S3 and kind of the uniform security policy, there's a question about, does Hammerspace handle things like worm, anti-ransomware, regulatory compliance for like Tier 1 and 2 financial firms? Can you talk about some of those features that we have and perhaps some of our footprint in finance as well?
Sure. I mean, we have limited time here, so I'll just briefly address the beauty of having the global file system that spans all your storage is you also have non-disruptive global data services that can be applied. And so within Hammerspace, for a long time, we've already had things, multiple layers of protection, whether it's versioning, worm, other things that can be done within Hammerspace to globalize even your data protection strategy. So you're not dealing with siloed data protection. You can do global snapshots across them all. So there's definitely capabilities within there. And I invite you to contact us where we can go into more detail.
And then lastly, I know we're right at time, but is Hammerspace available as a service? We do sell it as software. It's sold on a kind of a per capacity basis. The second part of the question is related to if you want to test and validate Hammerspace. And I think another good call to action for everybody out there, go to our website. There's a prominent button right at the top that says Get Started. Go there. If you're ready to get started with Hammerspace, we can get you a copy of our software. We have a pretty tight process for doing that. And like I said, you can spin up a Hammerspace cluster in probably under 30 minutes, either in your data center or in any of the leading cloud platforms.
And it is
easy to get started.
It is in the main cloud marketplaces as well. So we've had customers that did everything from themselves directly within AWS. But the best road is to, as Eric said, go to the website, and that we can help you directly. I think we're at time. Any closing comments, gentlemen?
No, it's been great. Simon, thanks a lot for joining us.
No, thanks for having me. Very, very exciting, incredible, exciting set of announcements. Really excited to see the innovation happening here. So thanks for inviting me along.
And thank you, everybody, for your attention. This has been recorded and will be published. And please go to hammerspace.com where you can get the latest information, tech briefs, white papers, and everything that go into more detail about this new features. And with that, thank you very much, and we will call it a day.